The demand for more affordable electric vehicles is surging. While Tesla has uniquely managed to profit in this sector outside of China, other manufacturers are grappling with losses, pushing them to find ways to cut costs and expedite production. Gigacasting, often referred to as megacasting, is emerging as a promising solution to craft lighter, simpler, and more cost-effective EVs. Credited to Tesla as a pioneering technique, it's fast becoming the industry's new norm, with competitors pouring billions into this technology. For an efficient electric vehicle, the formula is simple: use more aluminum, fewer parts, and embrace simplicity. In today's video, we're exploring the exciting world of gigacasting and how it's revolutionizing the production of electric vehicles. Come along as we discover why this groundbreaking technology is turning heads across the industry. Don't forget to subscribe to our channel and hit the like button to keep up with our latest insightful content. Gigacasting, a brilliant step in the evolution of vehicle manufacturing technology, involves pouring molten aluminum into high-pressure molds to create robust parts. Traditionally, vehicle components were made by welding smaller stamped steel parts, which was more complex and material-intensive. Tesla has redefined this process, employing large-scale casts to build major sections of their vehicles like the Model Y and Model 3, significantly reducing the number of parts from over 70 to just one per section. This not only makes the manufacturing process smoother, but also results in vehicles that are lighter, cheaper to produce, and better in terms of noise, vibration, and harshness. Tesla's innovative approach also includes integrating the car's battery into the floor, streamlining production by assembling multiple parts simultaneously. This integration has notably shrunk their production line by 10%, showcasing the efficiency of gigacasting. Moreover, the flexibility in design allowed by casting permits the addition of support where it's most needed, optimizing the vehicle's strength without the excess weight. While aluminum is pricier than steel, the savings from reduced complexity and increased efficiency make gigacasting a financially sound choice. By combining this with advancements in battery technology, Tesla claims to enhance vehicle range by 14% and reduce the number of parts by 370. While Tesla continues to innovate with gigacasting, other major automakers like Volvo are starting to adopt this technology in their production processes. Despite the upfront investment, the long-term benefits of adaptability in manufacturing and the potential for future vehicle upgrades make this a strategic move in modern car production. Volvo, for instance, has incorporated casting into their new electric vehicles, demonstrating a commitment to evolving with technology. Gigacasting isn't just a new way to build cars, it's reshaping the very foundation of automotive manufacturing. Imagine reducing a car's body from over 70 separate pieces down to a single part. That's exactly what Tesla has achieved with its Model Y and Model 3. This innovation not only streamlines the assembly process, but also enhances the structural integrity and overall quality of the vehicle. The magic of this method lies in its simplicity. By using large, high-pressure die casts, Tesla replaces complex assemblies of stamped steel or aluminum parts with single, robust aluminum casts. This change significantly cuts down on the number of joints, which reduces potential weaknesses and lessens the weight of the vehicle. Lighter cars mean better performance and increased efficiency, which is crucial for electric vehicles that carry heavy batteries. But Tesla isn't stopping there. The company has integrated this approach into the design of the vehicle's very structure, including the floor, which doubles as part of the battery housing. This integration not only optimizes space, but also adds to the vehicle's rigidity, making it safer and more durable. This strategic design choice also simplifies the production line, reducing it by about 10% and allowing for a more compact and efficient factory setup. Casting allows for more innovative designs too. With the flexibility to mold aluminum into complex shapes that stamped metal can't achieve, designers have more freedom to optimize parts for performance and efficiency. This capability is particularly valuable when trying to distribute the weight of a vehicle strategically to enhance handling and stability. Financially, gigacasting makes a lot of sense. While aluminum is more expensive than steel, the reduction in labor and manufacturing complexity significantly lowers overall production costs. Tesla reports that their gigacasting process, combined with advancements in battery technology, has the potential to reduce the weight of their vehicles by about 10%, extend their range by up to 14%, and cut down the use of parts by nearly 370. Industry response has been enthusiastic, with other major automakers taking note of Tesla's advances. Companies like Volvo and Ford are also beginning to explore the benefits of gigacasting, investing in the technology to stay competitive in the rapidly evolving electric vehicle market. These investments are not just about following trends. They're about setting new standards in automotive design and manufacturing for the future. It's important to understand its ripple effects beyond just manufacturing efficiencies. This technology isn't only about making cars cheaper to produce, it's about shifting the entire industry towards more sustainable practices. The use of aluminum in car manufacturing, while more costly upfront, contributes significantly to the long-term sustainability goals of reducing carbon emissions. Lighter vehicles consume less energy, which is pivotal for extending the driving range of electric vehicles. But what does this mean for the broader industry? As Tesla forges ahead, other automotive giants are not far behind. Volvo, for instance, has integrated gigacasting into its manufacturing strategy, seeing it as a key component in its shift towards full electric vehicle production. This move is part of a larger industry-wide transition towards building more environmentally friendly vehicles that are not only easier to produce, but also better for our planet. This adaptation requires significant investment. Building the infrastructure for gigacasting is not cheap, but it's a cost that can lead to considerable savings in the long run. For example, Volvo's commitment involves substantial sums funneled into updating facilities and training staff, illustrating the serious bet the industry is placing on this technology. The transition also presents some challenges. As with any innovative technology, the shift to gigacasting involves overcoming initial hurdles, such as the high setup costs and the learning curve associated with new manufacturing processes. Additionally, there are concerns about the repairability and recyclability of large aluminum parts, which are crucial factors for sustainability. Automakers are diligently working to address these issues, aiming to refine the process to reduce waste and enhance the life cycle of vehicle components. Despite these challenges, the excitement around gigacasting is palpable. Automakers around the world are closely watching Tesla's advancements and are eager to replicate its success. The industry is at a tipping point, with gigacasting poised to become a standard practice that could redefine how vehicles are built. This shift is not just about innovation for its own sake. It's about paving the way for a more efficient, sustainable, and profitable automotive future. If you're as intrigued by these advancements as we are, don't forget to hit that like button to show your support. Subscribe to our channel for more deep dives into cutting-edge automotive technologies, and stay ahead in the fast-paced world of electric vehicles. And if you have any thoughts or questions about today's topic, drop us a comment below. We love hearing from you. Thanks for watching, and keep an eye on the road ahead, because the future of automotive technology is just getting started.